Hello and welcome to our discussion of Module 6 in Big Data Analytics. So, moving into the overview. In this module, we're talking about Spark Machine Learning, so Spark ML. And it's a library that's part of the Spark ecosystem. By the end of this experience, you should be able to appraise the use of frequent pattern mining, also be able to evaluate an application to format data for use within Spark ML, and then argue how classification and regression are important in machine learning. So, machine learning and advanced analytics. So, what is it? The basic idea is being able to use AI techniques at scale across large quantities of data. So that's one of the challenges we've had historically, is being able to apply some of these techniques across all of our data rather than applying it simply to a sample. Why do you use it? Well, sometimes you use it to find patterns, to make recommendations, look for bad things such as anomalies, and so on. Common uses include things like fraud detection, product recommendation, image recognition, and so on. The basic pattern that you'll see with a lot of this sort of stuff is you take data that's coming in from a raw sort of location that might be coming in from a relational database, some files of various types, and then typically we do some pre-processing, some cleaning, some feature engineering. So we take some of the features that may exist and turn them into something more like what we want them to do, to be. Once we've done that, we take a look at using various models and techniques to figure out what provides the better outcome based upon what our definition of better looks like. We oftentimes tune them and adjust the hyperparameters, which is a fancy way of saying the settings that goes with each of the individual modules. And along the way, we do evaluation using our test set to determine how well we did. And then depending upon that, you may actually deploy it at scale and start using it in a production sort of environment. There are various types of learning. Supervised and unsupervised are the ones that you may hear the most about. In a supervised learning, you start off with a labeled data set, and it's basically based upon either historical or known values that are used to predict outcomes in the future. So you typically will do things like classification in this sort of world, where you're taking something and seeing if it is something or isn't. So is it a dog or not? You may also do multi-class classification, where you decide which of several groups something belongs to. It's a cat, or it's a dog, or it's a parakeet. And then also we may do things like regression, where we take some values and then try to figure out what the outcome will be. And it's a continuous number typically. So think of that as like something like sales. It's not either yes, I have a sale, or I don't. It's how many millions of dollars of sale might I have, and that's the idea of being able to predict something with regression, is figuring out the average number of days that a device may continue to function correctly based upon various factors up to this date. Recommendations is whenever we do things like predicting something that you might want. So think of your classic streaming service, your favorite streaming service. So be it Netflix, HBO Max, or Amazon Prime, or Hulu, or whatever it might be. Most of them will make a recommendation to you these days. So they, based upon what you've either watched in the past, or maybe it's your demographic profile, whatever it might be, it's used to say, hey, other people like you seem to like this, or other people that have watched the shows that you have watched have also watched these other shows, so maybe you should watch them. It started off as shopping cart analysis. That's where it kind of started, in particular with online retailers. So your e-commerce companies were some of the first to do this because they had access to the information. That's why whenever you're adding something to your cart, it might show you, hey, do you want to add this thing too? Sometimes it's good and sometimes it's not so good. But that's also something to keep in mind with any of this kind of stuff, is there's a certain percentage of error. There always will be. And that's why we have to be very cautious of when we apply any of these kind of technologies in situations where the outcomes are very bad if something is incorrect. Unsupervised learning is things like anomaly detection, segmentation, topic modeling, and clustering. Basically, you don't know what set something belongs to. You just know that some of these things might have something to do with each other, and so we put them together in some fashion. Graph analytics, another form where you're basically similarly looking for patterns, topologies, or whatever it might be within a network or a connected set of things, such as PageRank being the classic example. So early on, Google figured out that, hey, if we're able to detect with a high degree of accuracy the results that you're interested in based upon how important these pages are, and more importantly, how important are the pages that point at them are, then I can give you better search results. And that's the essential elements of PageRank. But there's a lot of other types of learning. I guess one that is worth discussion that's not in this list is reinforcement learning. The idea there is that you are given a way of determining how good something is. So if you think about it in terms of a game, it's a way of saying that if I do this, then I'm in a better place than if I do this other thing. And so the idea is that you teach it what good looks like, and it tries a balanced approach between trying something different that it hasn't tried before and trying something that it's done in the past that did pretty well. So it's that balancing between exploration of the search space and exploitation of known facts is how you do with reinforcement learning. So if we talk about the recommendation based on patterns, this is the shopping cart analysis. And the classic examples are milk, bread, and cereal, and sometimes beer. So the idea is that if you have somebody that has sugar and eggs in their basket, you might want to recommend bread and maybe milk, because those might be something that they're interested in. So the idea is that you do a certain amount of looking for patterns based upon historical values, looking for some sort of correlation between the items that are being purchased. Those that have a high degree of correlation you might make as recommendation. That's where this concept of association rule mining comes from. And it's looking for frequently occurring item sets, such as, in this case, A and B, satisfying some sort of minimal support threshold, which is basically a percentage of it's right more than it's not, or some threshold, so that it implies that if you're getting A, that you probably want B. And then there's also this concept of frequent pattern growth, where you're looking for frequency pattern growth, where you're looking for a way of determining the frequent item sets without necessarily generating candidates. And your idea here is that you're constructing essentially something like a tree to determine what things might be the good things to make a recommendation on. So the basic idea here is that if you think about it from your Amazon, you have a tremendous amount of transactional history that shows what people are buying. And maybe you're just a traditional brick and mortar store that has that kind of sales information, but not necessarily knowing who it was. And that's where e-commerce has a distinct advantage. Almost always they know who you are when you're making a purchase, so they can look at your patterns over time. But even without that, you can say that historically people come in and buy these 5 things together, or at least these 5 things plus some other things. So you may end up doing something like putting them either further apart so that somebody has to traverse more of your store, or you might put them closer together along with some other things that seem to be correlated with what they want. So you might put some of the beer next to the diapers, which is one of those classic sort of correlations that people talk about. But the basic idea here is that you're trying to make sense of something, of the patterns within a set of data, without necessarily knowing any sort of structural or having any sort of labeled thing that is what is the right approach. Moving on to what is Spark ML. So ML Lib, it's a package that provides interfaces for gathering and cleansing data, feature engineering, feature selection, training, and tuning of large-scale supervised and unsupervised machine learning models, and using those models in production, so a means of deploying them. There's this concept of transformers, which are things that convert data, estimators, which allow you to train your model, and evaluators, which determine how well you did. Moving on to an example. Let me get the right example. And I tried to spin up a cluster, and of course, here we are. So this is an instance of Databricks. You can certainly do ML Live without doing Databricks. And I'll also walk through kind of an example of how one pulls in an example in this sort of environment. So there's lots of different types of examples. We'll not go into the real advanced. We'll stick with this binary classification. One way that you can to play with this stuff is if you click on this copy link for import. What that did was put this into my clipboard, right? And so given that's in my clipboard, I can now come over into a Databricks environment, go down into a folder, and say I want to import something, and I give it a URL, and what I give it is that URL that it just supplied me with. Before this class started, I went ahead and kicked off or tried to start a machine learning cluster. This is just a cluster running a machine learning library. You can also do something similar inside of the free community edition of Databricks, and I'm having trouble finding the window. So I did something here. It's a little different. I had to delete my cluster. I set to create a new cluster, and I told it that I wanted the Databricks runtime 10.4 long-term support ML, so machine learning optimized. And by doing that, we can also run this getting started with ML Live notebook. So we'll go ahead and step through this one. I'll go ahead and clear all my state and output. Not that I've done anything, but just to be on the safe side. So this is a fairly classic example of doing some binary classification based upon somebody's income and geographic data. And so we do the typical steps that we just talked about. We do a load of the data set. We do some feature pre-processing, so you can think of that as feature engineering. We define the model, we build a pipeline, we evaluate the model, we do some tuning, and then we make some predictions. It sounds an awful lot like what we just talked about, right? So let's start off by taking a look at the data. This is a pre-configured set of data that is similar to like what you might have seen inside of RStudio and such, where it's a common data set that's available just kind of for everyone inside of Databricks. So they have a place where they put all their Databricks data sets, and that's what this is. We're looking at the first 1024 bytes of it. So just taking a quick look at the file, and so we can see there's not really a heading, so they give us a schema, which is useful, and more precisely it tells us that the first column is apparently their age, then their working class, then it's probably final wage, maybe, education, and so on. So with that, we're given this is a Python notebook. We've got a schema. We do a spark.read CSV, the name of the thing to read, and then we tell it what schema to use. And so at this point, they didn't do it, but it's always a good idea to take a look and see what that data set looks like. And so you actually want to call display to do a pretty sort of version of it. So we can take a quick look and see if it does look like it came in correctly. Always a good idea. They jump straight into, and you can see here that we can indeed sort these, and you could certainly do a describe or something to see what this info on it, see what the structure is. So the first thing they do is split the data sets into test and train, doing an 80-20 split, but it's not randomized. They're using a seed so they don't have reproducible outcomes. And then they're also telling it to cache the training data set, but not necessarily the test, and that's because test is not going to be used nearly as much. So what that's doing is giving it a hint that, hey, we're going to be using that a fair amount, and it's going through and counting the number of items in the train data set and also the number of items in the test data set. And then now we take a look at what the train data set looks like. And then we can take a quick look at the distribution of the number of hours per week. And this is basically a summary of showing you where the mean is, the standard deviation, the min and the max, and where the quartile distributions are. And a similar thing for education. Kind of just the breakdown based upon the groups. And so this is where we talk again about MLlib using these constructs of a transformer, an estimator, and a pipeline. Transformer does kind of like what the name implies. It does a transformation using the transform method to change the data in some fashion. An estimator is used essentially to do the equivalent of fit, and it's used by fit whenever it's doing the actual training. And then a pipeline is a combination of steps together. And typically these are similar to the types of steps that you've seen perhaps in other courses where you're training a neural network, for example. That might be another place where you've seen this sort of stuff. We do feature pre-processing to essentially do some work to get features in a way that we can use them. And then we convert these categorical variables into numeric. And in this case, there's a string indexer that converts a string value into essentially a number. So you're going to map between red, blue, and green to 0, 1, and 2. And there's also this one-hot encoder, which is going to turn a series of categorical values into a binary vector with various bits being on corresponding to what thing it might belong to. And typically it's only in one set. So now we take a look at what it's going to do. They've imported the string indexer and one-hot encoder, and so they're applying each to the various sets of, looks like, categorical values. The thing with Spark is that like this didn't necessarily do anything because we told it what we want to happen, but we haven't done something that caused it to be essentially evaluated. So that's one of the things. Spark is lazy in the sense that it does lazy evaluation. It doesn't do something until you actually tell it to do it, which is likely going to happen here at the point that we're calling fit. So we're telling the string indexer to fit the training data. Likewise, we're telling the string indexer to do a transform and on the training data. And at this point, we should have these various types of categorical values based upon, or these indexed values based upon the categorical values that were here otherwise. So sex is either 0 or 1, race is 0 to 4 perhaps, and so on. So it's basically turning them into things that are much easier to work with inside of a machine learning library. So now we're going to convert all of those feature columns into a single feature vector, and we're doing that so that it's easier to do our actual training. Here we're creating a logistic regression model with the features that we've just set up. And this is where the concept of a pipeline comes to play. So pipelines are a series of processing that you do, and generally there's a couple ways that it can be done. In this case, we're creating a pipeline, and then we're telling it to fit something, and then to transform. So this is one way of doing it. It's basically telling each one of the things what comes next, so to speak. There's other ways that you can create them where you basically, similar to what you do in Keras or something, where you're saying here are all the things that occur in the sequence that they occur. So you create a sequential pipeline, add them to. This is not a bad way to do it either. It depends upon, to some extent, programming styles and also the library. I've seen MLlib ones being done the other way, but this is a little simpler perhaps to understand. And at this point, you'll also notice that it logged an experiment. So this is MLflow that's being used inside of Databricks to keep track of each of the experiments that are being ran. MLflow does several things for you. One of them is keeps track of the results of various things. It also allows you to do things like deploy a particular trained model and use it in a production sort of scenario. And it's probably going to take a little bit to run. This is not a terribly big cluster. It's a single node cluster that I'm running on. One, it's a single node community edition cluster, so probably not going to be terribly fast. You can open up and see what's going on inside of the job and see how close it is of the various sub-jobs that are going on. You could also, looks like it may have just finished yet, took a couple minutes, not too bad. Then we can take a look at the features, labels, prediction, and probability. And then we can evaluate it, in this case looking at the rock curve. And then this is moving into a binary classification evaluator, so it's evaluating it using this evaluator, so a binary class and multi-class evaluator. And the accuracy isn't anything to write home about, but it's not, I guess, worse. It's better than average, right? So 76.8%, not too terribly great, but that's probably where we do things like tuning the parameters. And this looks like it's creating essentially a grid to do a search of the various parameters that might do better. And then we're creating a cross validator. And then this is actually making some predictions and evaluating the model's performance. This is showing, after it finishes that, it'll be showing us the way that you can take a data frame that is what was the result of that transform and then turn it into a view, a temporary view. And that allows you to go out and use SQL statements against it to do what we've done in the past, so that sometimes it's easier to write SQL statements than it is to write something in Python or Scala to do similar operations. Sometimes it's just more intuitive. Go ahead and key those up so that they will run as soon as they get a chance. The good news is that you are able to run the machine learning runtimes in the community edition. There's some of these sort of tools where they lock that kind of thing down so that you're not able to do so. So it looks like it's doing a threefold cross validator and it's finished one run. So we probably have a couple more to go. The technology behind this is actually pretty amazing, that they're able to distribute this stuff across numerous jobs and coordinate the results on something that's as complex as machine learning. And little oddness there with the progress bar. If you'll notice, it thinks it's done and then thinks it isn't. Not too sure if that's because it's guessing of how long it thinks things are going to take and they end up taking longer, or if there's more things being introduced. But reminiscent of some of our experiences long ago with Windows progress bars, right? Because it's definitely jumping back and forth. Looks like I just did 10 runs. So this is apparently this is when we're using the the parameter tuning. So what it's doing right now is actually trying out hyperparameters across the grid that we gave it earlier. And so that's why we're taking lots of different runs. You can see some of these appear to be doing pretty well. Have to wait for it to finish. We'll go ahead and look a little bit ahead because I think we're near the end. So the basic idea here is like what I talked about, where we are taking the model that has been trained, running it through on the test to see how well it does against test, and then telling you the accuracy. Then to do some evaluations of that output using SQL. I'll go ahead and queue up the last one. Rather than sitting here and waiting on it to run, we'll go ahead and shift back and move into the discussion of Deliverable 6. So the competency is to apply Spark machine learning library in the context of Apache Spark. And your criteria is based upon the rubric, as they always are. You still work at Big Data Connections Inc. It's still an international data clearinghouse that provides data services to thousands of its customers. DBCI has been a leader in solving its clients' problems utilizing Apache Spark. Spark's machine learning library has allowed BDCI the ability to use different learning algorithms for various tasks such as collaborative filtering, clustering, and classification. DBCI's existing and potential clientele need to become aware of what the company can do for them. As one of BDCI's leading data scientists, you have been tasked to assist the marketing department in developing an ad campaign that will provide much needed information on what the company can do regarding machine learning. The marketing department feels that exposing BDCI clientele to a variety of content in different formats will reach a larger segment of its existing and potential customer base. As part of the ad campaign, the company wants you to write an article and create a short video to be included on the company's website. So you're to create a video directed to BDCI's customers that include an explanation of what machine learning is and what it can do, a description of the different types of machine learning models, their purpose, and how they compare to one another, and then provide examples of each. Since your audience is made up of non-technical individuals, you will need to use layman terminology in your presentation and examples. Your video must be professional in content and tone. Record your video using a Screencast-O-Matic or some other video recording screen capture application of your choice. Use Microsoft Word to write an article that will be placed in the company's webpage. The intent of the article is to provide additional information that will complement your video presentation. The contents of the article should be written to address the target audience of non-technical customers. It should include the following: through the leveraging of two algorithms, content-based filtering and collaborative filtering, solutions can be determined. This technique is known as a recommendation engine. List 4 factors that can be used in a recommendation engine. Explain and provide examples of each factor. Then provide a definition of Apache Spark. Explain how it is used and provide examples. Provide a definition of Scala and how it is used and provide examples. Several resources that might be useful. The first criterion is that a thorough and detailed video has been developed that contains a description of what machine learning is and its purpose, along with the different types of machine learning models, their purposes, and how they compare with one another. A thorough and detailed article, free of errors, has been written that provides additional information that complements your video presentation. The article contains 4 factors that can be used in a recommendation engine, and an explanation and examples are provided for each factor. And then the article is free of errors, provides a definition of Apache Spark, Scala, and explains how each is used and provides examples of each. Moving on to a discussion of Deliverable 7. Your competency is to apply the MapReduce paradigm to solve programming problems, demonstrate file I/O within a big data environment, develop SQL-based solutions that will be applied against an Apache Hive table, solve basic data manipulation problems with Scala and Spark, solve problems utilizing Apache Spark and Scala, and then apply Spark ML in the context of the framework, and then we'll use the rubric to grade it. So the National Institute of Cooperative Enhancement is a big data consulting firm that has hired you as one of its many data scientists. In your new role, you will work closely with the company's board of directors. You will provide information on big data and how the proper tools can extract actionable insights from the company's many corporate clients. The members of the board are somewhat familiar with big data, but it is your job to provide them with explicit information whenever the need arises. You will have decided to create both Apache Hadoop and Spark clusters in HD Insight that will illustrate the various intricacies involved when working with big data. Feel free to do this in the Windows Subsystem for Linux environments you've already created. You will present this information in a report to the board of directors. So as you can see, this is kind of pulling together everything you've done in the course so far. So use the links in the resources section below to perform the following. Create a Hadoop cluster in Azure. The cluster will be utilized in the first 3 steps below. Follow every step provided in either Quick Start Create or whatever. Create a Spark cluster in HD Insight, and note that if you're doing HD Insight, you'd want to save things into a data lake, not into the cluster, because you wouldn't want to leave it there because you wouldn't be able to get to it unless you have the cluster existing. Also, you want to delete the cluster when not in use. So in general, feel free to use Windows Subsystem for Linux. Very viable alternative, in fact, lower cost. Complete the steps below to write a report for NICE's board of directors. Refer to use MapReduce in Apache Hadoop on HD Insight to run the MapReduce example word count application found in the examples jars, blah, blah, blah. Cluster. Use one of the 3 methods provided in the table. Include the following in your report. Tell me what you think about MapReduce. Explain the entire process of MapReduce and how it works. Include screenshots of your work. Explain what HDFS is, the Hadoop Distributed File System, and the role NameNode plays regarding client privileges. Include the following: read and write operations involved in HDFS and how the client interacts with the slave or worker nodes and the driver or master nodes. Develop a simple Java program that writes files to and reads files from HDFS. Word count is certainly that. And then include a screenshot of your work. HD Insight contains example data that can be used in Hive. Look in examples data and HDI samples directory located in the clusters. use HiveQL, works much like SQL, and uses many of the same commands in the same way. Write 10 HQL statements that transform, filter, and visualize data, provide data storage locations for Hive, show your work, and provide an explanation of each statement. Then number 4 is Spark has overshadowed Hadoop in many ways. I think that would mean MapReduce most likely. But anyway, Hadoop is based on batch processing of big data that's been stored over time, while Spark processes the same type of data in near real time, or it can, which allows for near real time analytics. Spark can also handle batch processing like MapReduce, but does so up to 100 times faster, especially if it's in memory. So create a notebook, write 10 Spark QL statements that transform, filter, visualize data, show your work, and provide an explanation of each statement. That can certainly be a Databricks notebook rather than dealing with Jupyter. Scala is 10 times faster than Python, maybe, but probably not in the context of Spark. Anyway, when performing data analytics and processing, it is also used for supervised machine learning tasks when used in conjunction with Spark ML and ML packages on Azure. So basically, find some prepackaged notebooks that have some code that does some Spark ML stuff similar to what I just showed you. As mentioned above, the Scala Spark frameworks can be used for supervised machine learning when used in conjunction with Spark ML packages. Spark ML is used for big data applications that have been built using data pipelines. Spark ML utilizes data frames as the foundation for its machine learning APIs. Define and explain what a machine learning data pipeline is and how the Spark framework can be used for their development. Some resources that you may want to consider, although I would strongly recommend doing this in the Windows subsystem for Linux. So a thorough and detailed report has been written based upon running word count using one of the 3 methods provided. Talk about the benefits and drawbacks of MapReduce. Details on how it works and screenshots have been included in the Word document. The report explains the read and write operations involved in HDFS and how the client interacts with the various nodes, and you've got some screenshots that show that. 10 HiveQL statements have been written that correctly transform, filter, and visualize data. Storage locations for Hive along with correct examples of the work completed and an explanation of what each statement is doing. A thorough and detailed notebook has been created with those 10 statements in it, and maybe with some markdown that tells us what they're doing. And then the report includes some code that talks about review of observations and outcomes, and the report is free of errors. And the report defines what machine learning data pipeline is and how it works inside of Spark, and in particular Spark ML. And with that, we can switch back and see if anything finished. And it has. So we can basically see that the accuracy is up to 84%, 84.5% by having done some hyperparameter tuning. And we can also do some analysis of what did the best and worst. So not surprisingly, not knowing their occupation is kind of hard to predict. But anyway, and then here's a nice little graph of age and predictions and so on. So you get a sense of that, and so you may want to consider looking for something like Getting Started with ML Lib as your example notebook. And with that, I'll wrap this up. Thanks for watching. If you have any questions, let me know. Stay safe, and we'll talk again soon.